Good morning, everybody, and welcome to this year's annual event by Research on Interdisciplinary and Global Studies, for short RICS, which is a faculty-driven and led fluid network of scholars here at Montclair State University, and they hail from a variety of disciplines to sort of provide opportunities of interdisciplinary collaborations across different research fields. And what's important is that this network is trying to highlight global interconnectedness and the impact of local faculty scholarship. And of course, it's sort of also a showcase of the university's expertise and engagement through scholarly achievements, research, events, and activities. This event is also co-organized by the Polak Speaker Series, which is led by my dear friend and colleague who will be moderating the talk or roundtable today, Professor Alfredo Toro Carnevali, who is faculty at the Political Science and Law Department. The series features talks on international politics, bringing important and global stakeholders to you here on our campus. So we proudly present today's roundtable discussion on AI, meaning artificial intelligence, and inequity. The purpose of the event is to explore the ethical ramification of artificial intelligence in an increasingly interconnected world in which technology and humanity have become deeply intertwined. This initiative is a collaboration between the departments in the College of Humanities and Social Sciences and the College of the Arts, including political science and law, theater and dance, justice studies, and religions. So a special thanks goes really to Alfredo and also our colleague who is partly invisible because she'll be behind the camera today, Kathleen, Kelly, and anyone else that really made this event possible. And without further ado, I'll open up the floor my dear friend Alfredo, and enjoy the show. Thank you.
Thank you, Arnaud. I'm really thrilled to be here in such great company. We have with us Dr. Kate Sitchio and Dr. Mona Sloan. I'm going to introduce Dr. Sitchio first and then Dr. Sloan. And we're going to start with a presentation by Dr. Sitchio, followed by a presentation by Dr. Sloan. Then we're going to have a few minutes for you to ask all the questions that you've been always wanted to ask about artificial intelligence and inequity. All right. So let me introduce Dr. Kate Sitchio. She is a choreographer, media artist, and performer whose work explores the interface between choreography and technology. Her work includes performances, installations, web and video projects, and has been shown in Philadelphia, New York City, Canada, Germany, Australia, Belgium, and the UK. She has been written about in the press in the New York Times, The Guardian, Days Digital, El Diarios, and Empirica magazine. She has presented work at many conferences and symposia, including the International Society of Electronic Arts, ACM Creativity and Cognition, Digital Research in Humanities on Arts, and others. Her PhD focused on the use of real-time video systems within live choreography and the conceptual framework of choreotopology, a way to describe this work. Please give her a big round of applause to Dr. Kate Sitchio. I'm going to go ahead and introduce Dr. Sloan. She is a sociologist and internationally recognized expert on the social implications of design and technology. Her work focuses on the intersection of inequality and artificial intelligence, and she frequently publishes and speaks about AI, ethics, risk, equity, and policy, particularly in the US-EU context. In 2020, Dr. Sloan was named to the Women in AI Ethics Hall of Fame for her exceptional contributions to the space of AI ethics and diversity. She was also named one of 100 brilliant women in AI ethics in 2019 and 2021. At NYU's Tandon School of Engineering, Dr. Sloan serves as an affiliate of the NYU Center for Responsible AI, where she focuses on conducting cutting-edge interdisciplinary research to develop, implement, and disseminate best-in-class open-source tools and frameworks for operationalizing responsibility at all stages of the AI cycle. She has a PhD from the London School of Economics. And please welcome Dr. Mona Sloan. All right, so Dr. Sitchu, Kate, I will give you the floor to start your presentation. And thank you for being with us virtually here. Thank you.
Yes, thanks so much for having me. Apologies that I didn't make the trip yesterday. A bunch of things happened when I was right about to leave. But yeah, I'm Dr. Kate Sicchio. I'm coming to you from the land of the Powhatan people, which is Richmond, Virginia. Just to give a quick visual description, I'm a white woman with brown chin-length hair and dark rimmed glasses on. And today I'm going to specifically talk about some of my work that involves machine learning and AI, and sort of my approach to using these tools. So I'm just going to share some slides now. Okay. Great. So yeah, over the years I've worked with a lot of different technologies. I've, as you've heard in my bio, I've done stuff with real-time video. I have a large practice that's intertwined with something called live coding. But today I'm specifically going to talk about some machine learning choreography I've done, and how also AI feeds into some current work I'm doing with something called choreo robotics, where choreography and robotics sort of meet. Oh, my little GIF isn't playing, but one of my favorite algorithms is a machine learning algorithm called a T-SNE. And what happens in a T-SNE is it stands for T scholastic neighboring embedded, and you can feed it a large set of data, and it can find similarities in those data and then sort of map it. So the first time I saw this was actually from someone called Gene Kogan, who has a project called Machine Learning for Artists. This was around 2015 or 16. And as soon as I saw this sort of mapping that it could do, I was like, this could be a dance. I need to make this into a dance. So I started taking photographs of dancers and putting it into T-SNE. So here's like a result of just over 1,000 photographs, maybe 1,200 photographs. So I would have a dancer improvise. I would use a GoPro to take about 2 photos per second, feed all of those into an algorithm, and then it would start to map, put them together in these sort of clusters where things that were similar are next to each other, right? So you can start to see like, oh, here's where her leg is up, and maybe the arms are out, and then if you look down, oh, the arm's still out, the arm's still out, and then it kind of shifts, right? Or like this section, you can see there's a, like, she's kind of going out of the frame, right? So it can see these similarities, but that also means that you can sort of like, from one frame to another, you could connect those, right? Because they're similar, right? You're not gonna have like arm up in one, and then like in a handstand in the next one. Right? There's like a transition that the algorithm does for you, which I found fascinating. Here's like the close-up of the one I just showed you. So you can really start to see the groupings, like here's all the like arms in a circle, right? Here's all the forward folds. Yeah, I've used this in a lot of different projects now. So one project was actually a bigger live coding project where I wanted these sort of to be able to call these groups of photos up during a performance and then a dancer could respond to them. And so I had my T-SNE and I made these clusters, and then because I like wanted to do something embodied with them, I guess, I printed it out, right? I made it analog, I made it paper and put it on my wall, and then started drawing on it, right? And actually manually highlighted the clusters and named them. And I did this with the dancer. The dancer in the photos is named Marissa Forbes. She was my research assistant for a couple years at Virginia Commonwealth University. So yeah, we did this sort of like real, we took this digital process and made it really analog by drawing all over it and like thinking about naming, and that's how we use the categories in that piece. I also used the same algorithm in a bigger choreographic process and made a piece called What the Computer Can't Do. So this was a work for, I believe there were 6 dancers in total, that are all BFA students at my university, and this was like for a faculty concert. So for this process, I did the same thing. I took thousands of photographs of them. We decided to play with this idea of color as well, so each one of them had like an individual color, because we wanted to see, if it would start grouping things by color as well, if it would kind of recognize that, and it does. Here's like a smaller close-up of some of this, right? So we had like some phrases that we did, we had some improv we did, we had some just like walking around, and then we had the order algorithm sorted. And then we learned the dance frame by frame, which was exhausting. And this is like, this is a close-up of the thousands of images we used. We ended up only like being able to do maybe like a couple hundred, like we did a couple rows, and that was 10 minutes of choreography. So what became really interesting about this process is that you couldn't just like, this idea of like moving from frame to frame, yes, you can do that, but there's still this idea of like, how do I move in between? What does it mean to like, okay, the picture is here and it's here, but am I like doing it slow to get there? Am I going directly there? There's still all these moments in between that as a dancer you have to figure out. And that became really fascinating, like injecting sort of this human movement into something that had been completely reorganized by a computer. And I have like a short, like, pretty much barely a minute of some of what that work looked like. Yeah, so this like tweening, I like to call it, which is like an animation term from when people used to make things for the web and Flash. But this idea that like we have these keyframes and then we have to fill them in because the computer can't do that part. Another piece I'll actually talk while I play a little tiny clip of this. I recently did a work with a collaborator at Old Dominion University, Yan Liu, and it was actually as part of a cybersecurity research project. And the question we sort of posed was like, well, what if we use AI rather than to identify people? What if we use AI to make it so you can't identify someone? So these images you see that are like watercolory blobs are videos of dancers, which I put through a style transfer process. So I like literally was like, here's some like inky watercolor aesthetics that I like. Can we use that to hide someone's identity when we're using video or imagery data, because we can still see the movement and we can still kind of see what they are, but now maybe we don't know who they are. So that was another recent project, sort of this idea of flipping what, instead of AI identifying us, AI stops stomping us, yeah? And then lastly, I've been working with robots. One piece is called Amelia and the Machine. I'll sort of talk over a short video. So in Amelia and the Machine, we're really interested in how we can interact with robots, how we can teach robots movement. And part of that is developing different AI approaches. So what you're seeing here is you see Amelia, the dancer, actually moving the robot arm 3 times. And this is actually, you're witnessing a machine algorithm we created. So the robot learns that movement, whatever you do, and then it weights them. So it's like, okay, the first one was the closest to what we think it should be, right? And it does this all instantly, and now it's learned the movement, right? So she can teach a robot a movement basically in the performance. And then this, that gesture comes back throughout the performance. We slotted in later, right? So through this idea of like, we have this idea that robots should learn from dancers because dancers are experts at moving. And this was like our first approach of doing that. We also recently have started working with spatial algorithms and moving the robot around the space in response to where the dancers are, which is a work in progress for sure. We just started a first showing in January, and we're hoping to continue that in the fall. But I guess to sort of summarize, when I work with these AI systems, I'm always interested in where my data comes from. Usually I'm the one creating it, and that's important to me, that it's not like scraped from somewhere. Can I use bespoke data, meaning like I'm going to use like a specific set for that piece and that purpose, rather than trying to be too general about things. I'm interested in algorithms that use small sample sizes, like Amelia and the Machine. And I'm also really aware of who's made my algorithms, right? Is it me? Is it another artist? Is it Google, right? Because all these things sort of start to play into who and where this work is touching and exposing and what I'm using. So that's just a little overview of some of my stuff I've been doing recently. So thank you.
Thank you so much, Kate. I'm going to go over, if I can, over that first grid that you showed us with all those movements, right? And I was reading that the first step is you have a dancer just sort of perform freely, just do the warm-up and then do some dance, and then even, maybe take a sip of water. That's all captured by a camera, right? And it's up to 3,000 pictures or something like that. Is that correct? And then it is that data set that then the algorithm takes. It looks at those 3,000 pictures. It seeks for patterns, reorganizes, and creates a new grid, right? Which is the machine's creation.
That's right. Yeah.
But then you don't just go and do whatever the machine told you to do. You use that as an inspiration. So you're using artificial intelligence, not something that you just follow blindly, but it's just, so the interaction between the machine and the human is the machine creates something that serves as inspiration for the human. And then the human takes that and creates something new. Is that a good assessment of the work that you did?
Absolutely. I'm interested in layers. I'm interested in I don't want to just put something into the machine and it spits it out and I'm like, that's it. I'm interested I don't really that might be interesting, but it's also not, like, it doesn't have my touch in it, doesn't have my hand. I'm not crafting it in the same way. So these tools provide inspiration, they provide possibility, they provide things maybe I hadn't thought of, right? But at the end of the day, I am not leaving it to the machine. I'm still actually putting my artistic hand in there somewhere. And that's important to me. I want to be able to like have the final say and final authorship. Yeah.
That's great because for me, from a, I'm not from a different perspective. It really helped me to understand how the machine works, right? How the algorithm works, what it does exactly, and how it interacts with humans, right? And the human has many options when it comes to its interaction with the AI. It could follow it blindly and just do whatever the AI says. Or it could do as you did, just use it as a source of inspiration to enhance the work. And I think that sheds light into the work of artificial intelligence and how it affects humans, not just in the artistic field, in the dance field, but in many other fields as well. So I thought that was fascinating. I have a question about wearable algorithms that you've worked with. What exactly is a wearable algorithm? Is that something that really tells you how to move, or is that something else?
Yeah. So my work with wearable tech, I do a bunch of different things, but one system I like to use a lot is using haptics. And I've used different haptics, but a lot of times I end up using vibration because it's really an easy one to work with. Like, I mean, everyone has a haptic sensor in their phone, right? You put it on vibrate, right? So yeah, so this idea that I use little vibrating motors, usually put them on dancers' arms because it's really accessible as well. But I can send sort of, two buzzes on the right, and that could mean to change something in the performance, or two on the left could mean something. So particularly with the spatial robot piece we've just been working on, the dancers wear these vibrating motors, and I'll give a command to the dancer, like, now you are attracted to the robot, and they have to start to follow the robot around. But at the same time, I might be telling the robot to be repelled from the dancer. So the robot's trying to get away from the dancer, and the robot's following them, or vice versa. So it becomes a way of transmitting like a score, is what I usually say. So there's still this level of interpretation from the human, like, how am I going to get there, how fast? Also, I have worked with dancers who are really seasoned improvisers and will also sometimes ignore my instructions because they're not feeling it in that moment. And that's super interesting for me too, because then it kind of becomes, I'm not like sending all the commands, as this higher octave, then it becomes a duet, right, and a dialogue. And I'm like, oh, they're not doing this now, so I have to rethink what I'm doing and see if I can send something else that's more interesting or that feels right to them in that moment. So yeah, so again, it's, I'm sending commands, I'm sending instructions, and that's where the algorithm comes in. But they also have agency as humans and might ignore it.
That's great. That's cool. Good. Thank you. Thank you so much, Kate. This is really interesting. I have a lot of questions for you, but I will wait until later. And I now want to give the floor to Mona, who is going to present to us on artificial intelligence and inequality.
Yeah.
Yes.
Let's do it. All right. Hello, everybody. Thank you so much, Alfredo, and your team for organizing this event. It's also really great to see all the students here after the pandemic. We're coming back to convening, which I think is really exciting. Before I start, I want to acknowledge that we're gathered here on the unceded land of the Lenape people. I also want to give a brief visual description. I am a white woman also with relatively short brown hair to my chin. I'm wearing a navy turtleneck and a red blazer and a large necklace in silver. Kate is a hard act to follow because she talked about all the cool stuff that you can do with AI and critique AI. I'm going to talk about geopolitics and AI regulation and sort of contextualize that with a landscape of AI harms that is emerging alongside this new technology. I come at this as a sociologist, as Alfredo said. I'm a research assistant professor and senior research scientist at an engineering school, but I actually come from the social sciences. And sort of my overarching concern in all of my work and the various projects that I do, some of them are actually also creative, but Alfredo didn't ask me to talk about those today, is a concern to develop what I call sociology of AI, and that really is sort of conditioned on two main observations. One is that those technologies that we call artificial intelligence really express and constitute social relations, and as such have become integral to how we organize society. I will give you some examples in just a second. Because of that, AI is not just a technical phenomenon, it really is a social phenomenon that is deeply entangled with wider cultural, economic, material, and political conditions, as I will also show you in a moment. Now, let's do a little bit more scene setting. Those systems that we call AI are everywhere. Whether we are aware of it or not, we are using and co-producing AI in our everyday lives. That starts at the autocorrect and film features on our phones, or in word processing software, to content recommendation systems on your social media or on the shopping sites that you use. Those recommend content that you are most likely to engage with. So there's a prediction in here that's actually quite important as a design logic for AI. AI also really becomes more and more embedded into various kinds of professions. For example, the financial sector, we have high-frequency algorithmic trading, which essentially uses automated and pre-programmed trading instructions on price or timing or volume on the trade floor. We have algorithmic risk assessments, which, for example, automatically assess loan applications and have really changed how loan officers interact with and engage with and think about the concept of creditworthiness of people. We have a similar picture in the insurance industry where, for example, natural language processing systems, which are systems that analyze and use large amounts of natural language data. Things Siri for, of course, recently ChatGPT. Those NLP systems are used to assess clients' insurance risk or to automatically detect fraud. Of course, the marketing industry has always been at the forefront of technology use and prediction, not least because predicting what you will buy is kind of their core business. We have famously targeted advertising, but we also have AI in the medical fields, for example, in diagnostics, in public health, in clinical research, social control in public health. Think back to the beginning of the pandemic, where we thought about using facial recognition technology to control public space or the use of masks in public space. So there are plenty of these, and we are all using them all the time, whether we are aware of it or not. And because we are using them all the time, we are also co-producing them. But what is AI really? And the jury is still out on that, which is why I like to use this little comic strip. We don't really have an agreed upon definition of AI, but we have some technical distinctions that are quite useful. So, for example, we can distinguish between rule-based and learning-based AI. Performer is given a set of rules. Think back to the algorithmic trading, or think about AI used in games. Deep Blue famously, eons ago, the chess system. So the system is given a set of rules and it learns how to play best by those rules. The other one, the learning AI, is not given instructions. It detects patterns by itself and makes decisions based on that, or makes recommendations based on that. For example, whether a photograph shows a cat or whether that's you on your phone, trying to unlock your phone. Now, as you can see in this comic, some argue that AI really is just fancy statistics, but others argue that advances in data collection, in computational capacity, as well as new methods really make AI its own league. And that kind of conversation comes and goes in waves. We kind of had a little bit of a, it's just math kind of conversation recently, and then ChatGPT hit. And now we're kind of back into, oh, maybe we are moving towards a general artificial intelligence. So there's a kind of living ecosystem of AI meanings also. As a sociologist, I really appreciate this definition by Dr. Abate, who says, well, really what we're dealing with here is a class of computer programs that really are designed to solve problems and that are sort of in the business of decision making. And that for me is what I call the core social function of AI, problem solving and decision making, very often in the context or in service of bureaucratic processes or organizing social situations. What we should also bear in mind is that AI is not a single thing, it is plural. So when we interact and engage with it, it's really them. It's a bunch of systems that, especially when we're talking about machine learning, are continually interacting with us as individuals, but also with us as members of certain communities or communities of practice or geographies or groups of any sort, but also with each other. So when you, for example, think about a content recommendation AI, whether that is on LinkedIn or that is on social media or wherever it is, then there are multiple systems that interact with each other as well. The other thing that we really need to bear in mind, and this is where kind of the sociologist kicks in again, is that AI is a scaling technology. That's one thing that these systems really have in common. They are designed to facilitate decision-making, ultimately to save time and resources, and increase productivity and efficiency. So we're dealing here with a scaling technology. And in that sense, AI is really walking in the footsteps of many other technologies that have deployed various kinds of classification or categorization techniques in the name of making bureaucratic processes more efficient. From ancient library systems to punch cards to modern computer vision technologies that know the difference between the different people in your photograph. All of these are kind of techniques or systems that are designed to minimize situations in which individual human judgment is required, which really, and I'm going to go just for a second, walks in the footsteps of, for example, Lorraine Dastens, who's a historian of science and technology. Her work on rules. Rules have kind of similar social function, right? And so in that sense, AI really has an infrastructural quality. It's sort of in the background, it does its thing. For example, if you think about your own membership with this institution, as students, if you entered this institution, chances are that your application was at least in some way interacting with an AI at some point, or you will in the future. So the infrastructural nature of AI means that we are really not conscious of that very much. And that means that we only sort of see AI when it fails. That is sort of a characteristic of infrastructures. They are designed to be invisible, but sort of make our social lives possible. But we can only see them when they break down. In that sense, they're kind of boring. Usually, and this is important for what I'm going to say about AI policy, infrastructures support higher order projects, for example, in the realm of politics, national security, economics, or culture. So think about voting systems, think about the military, think about the stock market, think about theaters, and so on. Now, when they break down, we're painfully aware of them. When toilets break down, we all are painfully aware of that. Or when trains don't run because of the weather, or whatever it is. Information systems have long been considered infrastructure, for example, by scholars such as Susan Starr and Jeffrey Bowker, and many others. And they are infrastructures that are based on classification and categorization. That's sort of the information systems bit here. And because of that, they are entangled with the social logics of putting people into boxes, right? We will get back to that in a second. So AI is not just infrastructure, it is actually social infrastructure. My colleague at NYU, a sociologist called Eric Kleinenberg, has introduced the notion of social infrastructure, and he has done that with a focus on sort of the good parts of social infrastructure, the things that sort of help us create and sustain the social glue that holds us together. So infrastructures that promote civic engagement or social interactions. And he really focuses on libraries, but also on playgrounds, on parks and sidewalks, as well as community organizations, and so on. I would actually say, well, AI is social infrastructure, but it's sort of on the opposite end of the spectrum, if you will. It is not necessarily social infrastructure in the civic-minded way, but it does, of course, influence the breadth and depth of our social associations. Now, because we're dealing with classification and categorization at scale, and we are dealing with AI as something that supports decision-making and supports problem-solving, very often by way of prediction, we are also dealing with the issue of AI harm. And AI harm is something that we have heard of from individuals and scholars and activists and communities who are often disproportionately affected, negatively affected by AI systems and the classifications that underpin them. When sort of that happens in a low stakes context, such as the system, recommends a pair of sneakers to you, you buy the sneakers, you don't like them, that's not necessarily a big deal. But when that happens in a high stakes context, that can lead to AI harm that can last for a long time or forever. It can have catastrophic consequences. We can take, there are many examples of that, but we can take a famed one, and this is from a comic that I co-created with my colleague Julia Stojanovic, who's a professor of data science at NYU, and Pallavi Khan, who is a doctoral student in data science and the comic artist. This comic illustrates the case of autonomous vehicles, or more precisely, the computer vision AI that is embedded in the sensors in autonomous vehicles. And so that AI may not be able to recognize a pedestrian who's pushing and not riding a bike across a road and strikes the pedestrian. This actually happened in 2018 in Phoenix. A lot of you probably know about this case. when Elaine Hertzberg was fatally hit by an Uber autonomous vehicle whose driver was watching the show The Voice at the time. Another example are false positives in facial recognition technology that is deployed by law enforcement, which can lead to wrongful arrests that of course have a long tail of various consequences for the victims. The very important part to understand here is that these AI harms, these sort of failures of AI as infrastructure, are often mapped onto the existing fault lines of discrimination and oppression that already exist in society. So they map on to intersectional identity. So for example, through the work of Joy Buolamwini and Timothy Gebro, the latter being the scientist who was fired, one of the scientists who was fired from the Google ethics team, their work has shown that facial recognition technology disproportionately has false outputs or error rates for people with darker skin tones and women, for example. We have evidence of class-based bias in AI systems, for example, in the work of Virginia Eubanks, who has examined predictive analytics AI in the context of the welfare state and analyzing benefit distribution and child welfare. We know about gender bias in natural language processing systems, which is something computer scientists are interested in, and so on. So you can see that it sort of maps onto the fault lines that we already have in society. We can distinguish between different kinds of harms, although we don't have necessarily a very neat definition of harm yet. This is a pretty good overview. Essentially, broadly, we have allocative harms, which can be caused when the system doesn't or withholds opportunity or a resource for a certain group. So for example, if a facial recognition system was being used in the hiring context in a robot interview and it wasn't working for people with darker skin tones, then you could argue actually the system prevents people from getting access to the labor market. We also have representational harms, which can reinforce subordination. For example, Sofia Mojanovo has written a fantastic book called Algorithms of Oppression, where she shows how search algorithms cause representational harm specifically for Black women. Okay. Now, what do we do about that? Ethics has been a favorite sort of silver bullet for all these kinds of problems. We've seen ethics everywhere in the public discourse of the last 5 to 6 years, both in policy as well as in industry and in the academy. And this is where I kind of come to the policy bit now. We've also seen ethics play a really dominant role in national AI strategies. National AI strategies are not regulations. That's very important to understand. National AI strategies are essentially business plans or articulations of intentions that national governments put together that focus on questions such as how do we achieve and sustain leadership in AI through investment into research, through training the workforce, through making sure that we in the future prevent or protect citizens from AI harm. So they're sort of broad frameworks that then give direction to regulation, to investment, and so on. They also have geopolitical significance because AI has become such an important arena of power that through national AI strategies, governments really position themselves in relation to one another. There are 2 major elements that drive AI investment in national AI strategies. One is an economic concern, of course, and the other one is about national security. That can mean investment in the military, but that can also mean national security in terms of preventing or protecting national AI systems from hackers or from manipulation. And this is where I actually come to the last slide. Ethics really does very important work in these national AI strategies. It works as an umbrella for both boosting the national AI industry and for protecting citizens from AI harm. And it's quite interesting because ethics here is deployed to square the circle. And governments really cluster this around three concerns. One is governance, for example, ethics frameworks or ethics trainings or standards. That's something the US is currently trying to do. We have risk mitigation, which can focus on things such as privacy or robot safety, but also addressing issues around bias, and very much more technical design and deployment concerns, such as how do we actually create AI transparency and open up the black box? What are sort of liability, situations or relationships around liability that we can define? What about fairness and so on? And so we're now seeing the formation or the materialization of these concerns and actual regulations that are coming up everywhere, but predominantly in Europe and also in the US. And I'm going to talk about those and probably way over time, so thank you so much.
Many thanks, Mona. It's a fascinating presentation. If I can ask you just maybe, highlights a few things from your presentation. I can take that one lesson is AI algorithms are not neutral. Right? They are embedded, right, with all the imbalances and inequalities and cultures of discrimination that we see in society. So there is no, you can't hide it. It's the reality. As a political scientist with an interest in international relations, I needed to ask you a question because you talked how AI can actually exacerbate imbalances, not just between individuals, but also between countries. Right? And it can even reforge paths of colonialism. Can you say a little bit more about that? Because I was intrigued by that, and I can imagine how it works, but I'm not exactly sure.
Yeah, happy to. That's a great question. So the presentation is based on a study that I ran in 2018-2019, where I collected any and all national AI strategies that were available at the time. And what you could really see just in terms of what data I was able to collect, i.e. what national AI strategy thinking was available, really mapped onto sort of colonial patterns where we had dominance in Europe and in the Anglo-American sphere, very pointed attempts sort of in Central and Latin America. India at the time had a very expansive one already. But for example, when it comes to African countries, we had relatively little government sort of thinking around AI. When it was there, it was a lot more about corporate-driven strategy thinking around, can we build data center here? Can we create training centers here? So there was a corporate agenda that was sort of driving that in that part of the world. So in that sense, yes, but it also has changed since. This is data that is from pre-pandemic time. So there probably are sort of newer developments here, especially as the sort of no longer very new Cold War is polarizing yet again between East and West, and AI and AI-driven technologies and products really are at the center of that. You can see that when you look at, the headlines. Should we ban TikTok, for example? So it's sort of a renewed or ever heightened arena for geopolitical concerns and sort of push and pull very much.
Thank you. Thank you. Something else that I wanted to ask you, and you emphasized that there is no technological solution to the problem of inequality in artificial intelligence. That role must come from that. That solution has to be addressed from the perspective of society, from this perspective of culture, and that social sciences have a role to play in trying to address this problem. Can you talk a little bit more about that?
Yes, happy to. I want to preface that by saying I'm not I'm a techno-optimist. I do think there is an important place for technology generally, and most certainly for AI systems. There are huge leaps that are being made, for example, in clinical research through AI. So it has an important role to play, and it's also here, and it's here to stay. So I'm going to acknowledge that. However, what happens more often than not is that folks who design these systems, of course, bake assumptions into the systems, maybe not even consciously, but subconsciously. I can give you an example of a case that I actually worked with some colleagues. Again, Julia Stoyanovich in data science, but also Hilke Sherman, who's a professor in our School of Journalism, and Paul Squires, who's a psychologist. And together we examined personality assessment tools that are used in hiring. Personality tests are not new to corporate America. They've been around for a good long while, but they're now being automated. And we examined two systems or audited them, and what these systems do is they take either a resume or a social media handle, and based on that, determine a personality type. And then based on that, determine job fit for a role. All of that just based on a little bit of text. We can argue about that being problematic, but we can, with social science, and this is why it's so important to bring in social science, can actually examine the assumptions that are baked into the system. Here being the assumption that personality is something that is stable enough across time and across input factors and so on, that you can actually measure it. Then the other assumption is that that measurement is meaningful enough to determine whether or not you will be doing a good job in that role, okay? And we can, these assumptions are, again, often infrastructural, baked in. There are many of those, right? We know this, for example, on scholarship on risk scoring in loan applications, the effect of, zip codes here, which is, of course, very much in the US, entangled with racial discrimination, the redlining, and all of those things. So we can use the social sciences as a baseline and then use technical audit strategies to audit against those. And one of the things that we found in that study was that one of the tools determined a different personality type based on whether the resume was uploaded in raw text or PDF. And so we first determined the stability of personality was the thing that the system was trying to do from the social science research, and then technically just tested against that. And we're able to determine instabilities, which led us to conclude this is not a stable construct. 2, we can't measure it, and 3, because of that, it is not a meaningful thing to do in hiring, okay? So, but that's sort of based in social science techniques.
Interesting. Thank you, Mona. So let me, Kate, let me bring you back in. Thank you. Let me, for the sake of time, I'm just going to ask you one question, and then and then we'll open the floor for questions from the audience. So Mona, you have said that that artificial intelligence will evolve alongside rather than instead of humans.
Yes.
Yes. Kate, the work that you have developed puts into practice that concept, right? That it will be alongside, not instead of. So, can you comment on the future of, and we don't know what that is, right? But so we're always wondering what will happen. And we know we have many students here. I imagine that many of them may be worried about, is it going to be alongside, or is it going to be, are these jobs going to go away? Are these, is artistic work going to go away? Are things going to go away? Will we really be working alongside AI? If you could comment on that. And Mona too, both.
Yeah, sure. Yeah, I don't see, the thing we have over AI is the body. I don't see the body going away. Even like, particularly since working with robots, oh man, human bodies are much better. Robots, awful. Yeah, so I don't think we're going to be replaced. I think there's so much that the human body can do. There's so much that our brain connected to our body can do that I just don't see the computer figuring that out in our lifetime, like these connections, this this plasticity, this what we can bring just by physicality. And I do think the thing with working with robots in particular, which has been really interesting, is how much they need us and how much my project specifically looks at human-robot teams, because robots really need humans to guide them and to show them and to teach them how to move. And for me, that's also where the dance comes in. Is like, we know how to move. We're dancers. We can totally teach these robots. So yeah, I don't think I have no worry about AI replacing us because I don't think it's there yet. I think I think we need us and our bodies for sure.
Thank you, Kate. Mona, what do you think?
I love that, the body of a robot comment. Kate, our bodies are not going away. I think that should be on t-shirts. But anyway, I do agree, but I will also say that the narrative around large-scale displacement has been around for a long while. The sort of fear of automation is an old fear. If we look back in the United States at how automation affected productivity and wages, we can see that over the last 30 years, technology has actually increased productivity, but wages haven't kind of kept up with that. So wages have stagnated. So ultimately, what happened is that workers lost their stock into the growth of productivity and the benefits of that. So that is a function of reduced worker power, of less unions, and all of that. That is not a function of the technology itself. There are countries that have a much higher degree of automation, a larger manufacturing industry, for example, Germany, Japan, who don't have these sort of inequality problems that you see, for example, in the United States. So I think we need to acknowledge that this is what happened in the past. We need to acknowledge that the narrative serves a function and that it helps technologists stay relevant in the discourse, and especially in important discourses around the economy, around politics, around where we actually put money in terms of innovation. It can also do good things. We started talking about UBI, Universal Basic Income. of all countries in this country fairly recently because of the sphere of automation. So there is something that these narratives do. I think there is, I agree with Kate, the body isn't going away. But I also think that it is interesting that we can talk about inequality again in hopefully, no pun intended, productive ways.
Thank you, Kate. Let's open the floor for questions from the audience. I see David and then David first again. Oh, where? Oh, where about? Oh, and Chris. All right. Chris, go ahead. You first. Yeah.
Dr. Siccio, earlier you mentioned how you're mindful about the data sets you use in your work, like where you source them from, whether you make them or not. And I was wondering, like, what your opinion is on, like, ethically sourced data sets. So, like, an example would be, like, with how Stable Diffusion AI works. It works off of, like, millions of photographs and artworks, and there's a big debate on the ethicality of the use of that, because a lot of artists don't give consent for their work to be used in these data sets. So like, what can we do to like combat that, or like any kind of legislation or just general practices to get away from that?
Yeah, thank you. That's a great question. Yeah, it's a huge concern for me, which is like, because I have had like people from like computer science departments come to me and be like, oh, great, you can help me scrape all this data off the internet, and then we'll make an AI with it. And I'm like, no. There's like so many like layers to it. There's like, yeah, artists, trying to put their work on the internet to get recognition or payment of some time, and then it just being taken away from them, right? There's also this issue of like, if you're just scraping random data, there's bias within that set usually. There's all these like issues with that approach. I guess it would be interesting to see what kind of legislation that could help with. There's also like always been some tradition of like biting other people's work, right? And like we see this all the time on TikTok, right? Creators of dances don't get credit, right? Like the most famous TikToker who makes millions of dollars got famous for stealing someone else's dance, right? So like there's also like issues like that, which I don't know if we can like necessarily solve with legislation. Like we'll always have these issues of people trying to bite off other artists. There's like points where I think maybe we need to like be like, hey, this is where the ethics come in. Like, hey, maybe we shouldn't steal other people's work, right? Rather than like creating some kind of bigger law might not solve it so much. But yeah, that ethics silver bullet, right? Yeah.
I'd like to bring two elements from both of your presentations. I'm seeing autonomy, scaling, efficacy. There's an old phrase, quantity is a quality all its own. And to what extent AI's advantages seems to be it can make a lot of decisions and choices very, very quickly, much, much faster than humans. And so the human experience of autonomy seems to be associated with, I make a choice, it gets expressed. If AI can make those choices and decisions much more quickly, is there going to be a different kind of autonomy with AI? And to what extent does AI as something sentient looks very different because it can express itself in a way that humans can't, because it can make these choices so quickly. Go ahead.
AI doesn't make choices. It predicts what certain circumstances or situations could be. So we're dealing with correlation, not causation. So there's a likelihood of something being true that is taken as a basis for making a decision. That's why if you, for example, have an identical, twin brother, they might be able to open, your phone. So I think that's very important to understand. What is also important to understand is that, and Kate said this so beautifully and shows it in her work, this is all conditioned on us producing data. This is all conditioned on historical data. And so in that sense, ChatGPT works in the same way, for example, any natural language processing system. It sort of kind of guesses what the relationship between words is, which we socially mistake as meaningfulness, but it isn't meaningfulness. So I think this distinction is very important to understand. Now, the question around autonomy that you asked, I think, is a very, very important one. And I think that's an ongoing conversation that has, I think, a lot to do with what we mean by autonomy and who has has autonomy and power already in society and who doesn't. But I think a productive or meaningful conversation here can happen in the context of socio-technical systems. This is what happens, right? That these systems are embedded into how we organize society, how we relate to one another. And I think your question is extremely important in the context of professions. How is professional decision-making and discretionary decision-making, for example, in high-stakes situations or high-stakes professions, in the emergency room, in the courtroom, wherever it is, how is this affected by AI systems that get embedded into these decisions? And there's some interesting research that's also already going on in that. But I think this is, I think in that context is where we'll be asking the questions that you just asked.
Should I go back?
Yeah, okay. Ben.
Okay. My question is also for Dr. Snow. Thank you for a great presentation. So it sounded to me that in your response to AI harm, and correct me if I'm wrong, there are largely two different responses. One is kind of a corrective, which starts from the premise that AI is only as good as the data we feed it, right? Algorithms, respond to kind of human input. And then the second one seems more categorical, which is to say data-driven prediction should not enter certain fields of society. I was reminded of your personality type aspect, right? For employment, one can also think of prediction in terms of criminal behavior, et cetera, for all kinds of reasons that not just the social sciences, but also the humanities have something to say about. So I was just interested from your perspective as a sociologist who kind of applies ethics herself, but also seems to study how other people apply ethics. How you distinguish between those, as a techno-optimist, between those two approaches, a kind of corrective approach and the more categorical rejection of this over-reliance on data-driven predictability, and then on the other hand, whether you see in your own work, especially in the global context, a kind of a leaning towards the kind of corrective approach, let's say, right? That somehow only we improve our data sets and our algorithms, AI can eventually, solve all of these problems. So how much has the kind of more categorical rejection actually still some sort of hold in that debate? Does that make sense?
That makes sense. I would maybe Kate can also.
Yeah, Kate, go ahead if you want to jump in. Please.
I'll definitely respond.
I actually couldn't hear the last bit.
Okay, then let me go.
Okay, all right. Okay.
I think that is such an important question and also a very important observation between sort of this categorical rejection and sort of the tech fix, we'll just make it better kind of narrative. And as a techno-optimist, or an optimist, I should say, I see that distinction being featured more prominently and intelligently in public and policy discourse. In other words, we are getting smarter around the question, what is the system actually set out to do? What are the assumptions? What data is being fed into it? What are we optimizing for and to what end? And then, should we actually be doing that? So there is an interesting conversation that has been going on for years around refusal of AI systems. There's interesting art activism that's actually going on there as well. So policymakers are getting at that. In Europe, for example, we have the EU AI Act that we're expecting to kick in sometime this year, which is an omnibus regulation that sets out to regulate any and all AI systems in the European Union, regardless of industry or sector, and it does so through a risk assessment framework. And that risk assessment framework actually gets at that because it tries to understand what is the risk of the deployment of a certain system in a certain context. So it's trying to, do you know what I mean? It's trying to like grapple with that in sort of applied ways. I do believe that refusal or rejection needs to remain an option, ultimately. But there are also ways in which conversation we need to have about just making systems better.
Let me see if I can recap Ben's questions. But it's basically, if I understand correctly, and you let me know, Ben. But one part was there's a presumption that it is good to make decisions on the basis of data, right? And that the better the data, the better the decision. Now the other part of the question is, why are we making decisions based on data? Is this a good idea at all, right? And are there certain things in work and life that should not be based on data at all, and that we should just be based on different decision-making inputs?
Yeah, thank you. Yeah, I guess one of the things I guess I get to do as an artist is see if things have resonate with me, either emotionally or as part of a narrative or theme. So yeah, this is where that authorship that I like comes in. Like I do have the like eject button. I can like shut it down. I can start again. I'm not making I'm not in a courtroom. I'm not at a police station. I'm not making these like decisions that could impact someone's life in that kind of way. But I can look at data and be like, oh, maybe there is this narrative here, and maybe that's interesting, and I can start to pull that back. I think also, like I'm in another project right now where I'm like really curious if anything will come out of it. I think it might not work, but it's another robot project, but we're looking at biometrics as a way to see if the premise actually is that the robots shouldn't trust humans because the humans will make horrible decisions. And we're looking at particularly if if someone is doing something and they get tired, can the robot recognize a change in movement and recognize that, okay, they shouldn't be doing this job anymore, I'm going to shut off. I think it's an interesting premise, but I don't know if we can do it. Like, I don't think we, there's so many different factors to that.
It already happens though. If you have, in cars, right? Like if you have a new car and you sort of, they're all smart these days, but you are not perfectly between the white lines or whatever it is, it will say, oh, you're tired, you should take a break. And so that's really interesting because if that gets recorded and you get into an accident, maybe your insurance company is interested in that data. So that they're already trying the tired bit.
Yeah, and I guess what I'm thinking of more failing is like, that has like literally like white lines that you can measure.
Yeah.
Right? Like someone moving is a lot harder to see, if that body is not is now all of a sudden like slightly changing. So I guess it's more of, yeah, a question of like what kind of data we can do, like to track it. Like, yeah, I don't know if we have the right data, I guess is the question. Like, we don't have the white lines that you drive out of. So I guess that's where I'm dubious, is that like, yeah, what are we tracking? What will give us the right metrics? And I don't know. Right.
So we are running late. If you have to leave, that is okay. But we do have one more question from the gentleman here. If you want to go ahead, and this will be you. This will be yes. This will be the last question.
My name is Zach. My question was, do you believe the access to AI or lack thereof access to AI and government policies will exacerbate economic inequality or shorten that gap?
Hey, did you hear that?
So the greater use of AI by government will exacerbate inequalities.
Sorry, I still get it.
Will AI help us address inequality or exacerbate it? Right. Economic inequality. Yes. Do you want to take it?
Yeah. Go ahead, you go ahead. This is not mine.
Yeah, so it really depends on how it's being treated by governments in regulation and industry. I think it has huge potential. But ultimately, something like economic inequality and the distribution of wealth is not a technical problem, it's a policy problem. And that's where it has to start. This is where it starts and ends, ultimately. So, and I'm European, and as a European, I think we can't have that conversation without talking about taxing corporations, for example. So it's that's my opinion. Yeah.
All right, this brings us to an end. Thank you so much to Kate and Mona, Dr. Sikyo, Dr.
Thanks, Kate.
Thank you,
Thank
Kate.
you so much. Yeah, this is brilliant. Thank you. And again, apologies. I couldn't make it.